Hi guys, my name is Parag and welcome back in the part number 3 of 2 hinge arch numerical. So guys, in this video, I'm going to explain you how you can solve the normal thrust and radial shear at 8 meter and 12 meter from the left support, radial shear and normal thrust at crown and normal thrust and radial shear at 5 meter from the right support. So this is really very easy examples. Okay, you need to understand that this numerical which I am explaining to you since part 1 to part 3, it comprises of all different type of um, questions for the 2 hinge arch. So in your examinations you will get the questions, calculate the horizontal thrust and calculate the position and magnitude of maximum positive and maximum negative bending moment. Okay, you have or horizontal thrust with normal thrust and radial shears at different locations, right? So let's directly jumping to the point number 4. Okay, and I'll explain you how to do it. But before that, I just want to ask you, if you not visit my website, which is www.civilnotes.com. This is really good website for all of you who wanted to become who wanted to learn the civil engineering aspects, the numericals and everything, get examinations and different type of examinations, and also project management stuff, right? So let's get started. So I'm jumping to the point number 4. Okay, so let me directly take you over here, right? So you can see guys, this is point number 4. To calculate the normal thrust and radial shear at 8 meter from the left support. So this is really very crucial, right? So for this you need to understand, you need to draw this diagram. If you not draw this diagram, if you are failed to draw this diagram, let me tell you one thing, you are not able to do the calculations proper way. Understand? So before that, just understand what he's gonna say. They want to calculate the normal thrust and radial shear at 8 meter from the left support. So in your diagram, in this diagram which you have discussed in the part 1 and part 2, from the left support, okay, you have this area. Understand? So now what you have to do, you need to take this area, okay, here at this level. Okay, so I have taken this area over here, and now let me start adding the reactions and forces for that points. So you can see I have just added my reaction forces. Okay, these are the reacting forces, which is VD and HD. So this point, the crown point, I have mentioned, this is a crown point. Okay, so this crown point, I'm mentioning it as a VD and HD forces on that. So HD is the horizontal force, right? And VD is a vertical force, right? So horizontal force and vertical force, different type of forces I have applied on that crown point. Apart from that, you can see I have my horizontal thrust over here, okay? And I have my vertical reactions A. Okay, vertical, I can say support reactions, right? So this is what the clarification for this diagram. Understood? So we have just take a cut of this area, and we have added only these two forces at the point D, which is VD and HD. Now you might ask, why this VD force is coming downward? Okay, so there is some reasons. I'll definitely tell you these reasons in the upcoming videos. But the thing is, when you are supporting, the reaction forces is like there is an arch. We are supporting from bottom, but the forces which in acting on the top, they are definitely come downward direction. They will not go upward directions. So that's the reason we have considered VD at the crown point as this point like this, right? And the horizontal thrust, the HD, it is the reverse replica we need to consider for the horizontal thrust. That's why it's HD in this directions, from this sides to the this sides. Okay. Now, based on that, we need to distribute this diagram. Okay. Based on that, we need to distribute this diagram in different way, such as you can see over here, we have HD, we have VD. So we have HD, we have VD. So we need to draw a tangent to this curve. So this is a tangent we have drawn, right? So this is a tangent. I'm going to remove this one because already I have drawn. And there is a perpendicular tangent which is a normal we need to draw. So there is a two tangent. One is a tangent and another one is a perpendicular tangent that we need to draw. Okay. After that, we need to split these two forces in the two directions, such as the first one is the this directions and another one is this directions with the angle of theta, right? So we have distributed VD as a VD sin theta and VD cos theta. Okay. Similarly, the HD force we have distributed as a HD sin theta and HD cos theta with respect to this theta angle, right? So this is a two more value additions in this diagram we need to make before starting the numericals. Okay. Now you understand that we have the height of till the height of the crown, and this point we have the equation of y available in the horizontal thrust numerical, which is a y, right? So here we need to understand when we are considering this y equation, okay, we need to remember what was that equation, okay, while solving the numerical. So now just understand, we need to focus on this diagram instead of this diagram now. Okay, so let's start doing the calculations. So first of all, we need to calculate to find the reaction force VD and HD at the section using the condition of equilibrium. So when you are using the condition of equilibrium, okay, so all the sum of forces along the x direction we will be considering equals to 0, right? So 400, so what is going to happen is 400, which is a horizontal thrust, minus of HD equals to 0. So we got the value of HD equals to 400 kilonewton, right? Then let's consider the summation of all forces along the y direction equals to 0. So whatever forces are going in the up direction are positive and the forces coming in the downward directions are negative, right? So how it will happen is, so 600 is going from bottom to top, so it is positive, minus UDL. So UDL is 50 and the distance is 8 meter. So 50 multiplied by 8, right? So this is what we have got, minus VD equals to 0. So we got the value of VD equals to 200 kilonewton. Okay, that's very simple, guys. Just why I'm taking your time, because these diagrams are quite interesting. If you just miss this diagram, you will face the problem. You are not able to solve all these stuffs which I have mentioned here, right? So afterward, when we are starting working on this, we need to calculate the theta, because we understand that we have a trigonometric variations sine theta and cos theta. So this sine and cos theta we can only get resolved when we have that theta specification, that theta angle. Because as of now, we got the value of the HD, okay? We got the value of HD, we got the value of VD, but let's just start with the angle, which is theta. So to find that theta, let's understand we have an equation of rise, which is the y equation, as a 32 x minus x square divided by 32. That's correct, which we have calculated in the horizontal thrust numerical. Then we need to differentiate this with respect to x. So if we are differentiating this equation with respect to x, what will happen is it become 32 minus 2x divided by 32. So if you didn't understand this, let me tell you one thing very easily. So the equation is y equals to, it is 32x minus x square divided by 32. So this is the equation. I am differentiating this with respect to x. So differentiating the y with respect to x. So what will happen, guys? 32x. So x is there. So it will become only 32. Okay. X square. So 2 will comes at the first. Then x to the power will 1. 2 minus 1 divided by, okay, will be having only 32. So this is the equation which we have got. And that's what I have mentioned here. Okay. Now we know that we are just considering the dy by dx is the tan theta. So we know that the sine divided by cos is a replica of the tan, right? So sine divided by cos, so we are considering dy by dx is equals to tan of theta. So we have tan theta equals to 32 minus 2 into, let's put the value of x as a 8, because we have a distance of x equals to 8 meter. So it is 32, right? So we got the value of tan theta equals to 1 by 2. Okay, and if the tan theta is equals to 1 by 2, it means theta equals to, you can easily calculate the theta. So tan inverse of 1 by 2, which is 26.56 degree. So now you got the value of theta as a 26.56 degree. Is that correct? So now to calculate all these things, okay, you can easily do the work. So now, okay, the step number 3, to find the Pn and the PR. It means to find the normal thrust and the radial shear. So to calculate the normal thrust and radial shear, guys, okay, you need to do the summation of all the forces acting along the tangent. So how many forces acting along the tangent? Okay, that are hd cos theta, okay, hd cos theta, okay, and the vd sin theta, right? So these are the forces acting along the tangent. Understand? So hd cos theta plus vd sin theta, just put the value of hd as a 400, cos theta value we have 26.56, similarly vd 200, sin 26.56. So the pn value become, the normal thrust become 447.21 kilonewton, right? Now we need to calculate the summation of forces along the perpendicular tangent to get the what? To get the radial shear. So to get that one, the value would be, we need to take the value of hd sine theta minus vd cos of theta. Okay, so hd sine of theta minus vd cos of theta, just put the value of all the details. Hd we have 400, theta we have 26.56, vd is equals to 200, and theta equals to 26.56. So we have the value of radial shear, okay, as a minus 0.039 kilonewton. Understand? So this is what, guys, we can easily calculate the normal thrust and radial shear. Okay. Now if you just move for the next calculation, which is a normal thrust and radial shear at a 12 meter from the left support. So what I have done here, I have done nothing for that. You just look at the diagram and you can easily do this one. Okay. I'm going to provide you this PDF for all your reference, so you can easily look into it. Just I have drawn the VE and the HE at the E point, which is a 12 meter, which is a defined distance with respect to the numerical, right? So 12 meter is a standard one. You have VE, you have HE at the point of E, right? And based on that, I have done the two calculations of the tangent and the perpendicular to tangent to get the normal and radial shear. Understood? So now you need to make the change here as a 12 meter, my bad. Okay, this should be 12 meter. Okay, so what we're gonna happen is, guys, the same equation, same detail you need to identify. You need to calculate the VE and HE by making this equilibrium conditions for the summation of forces and the vertical forces. So you will get the value of HE and value of VE. So I have done nothing, guys. You can just see that horizontal equations value 400 minus of HE, you got 400. For vertical reactions is 600 minus 12 into 15 into 12 minus V is equals to 0. So now I am again differentiating this value of Y to get the value of theta. So I got the value of theta as a 14.03 degree. Is this very easy, guys, right? So now to calculate the normal thrust and the radial shear, I'm going to do calculation of summation of all forces acting along the tangent to get the normal thrust. So which is He cos theta. It is 388.067. And to get the radial shears, I'm doing summation of all the forces acting perpendicular to the tangent, which is AC cos theta, which is PR 96.97. Okay, only these two equations you need to take that one, because the value of V is equals to 0. So if you take any multiplication of that, it will be definitely 0. Okay, then similarly for the calculation of the normal thrust and radial shear at the crown. So crown, if they mention the crown, what does it mean? You already have a crown distance as a 16 meter, right? So just a very simple calculations, that whatever the distance they have mentioned, like do a 12 meter one, do a 8 meter one, and if they mention the crown, it means whatever the distance of the crown mentioned in your diagram, which is total is a 32 meter distance. So from this point to this point, distance is L equals to 16 meter. So the value of X will be 16. That's it, guys. I thought it is really very easy numericals. Okay, if you have any doubt, please let me know. And I just want to ask you to please do subscribe my YouTube channel. Okay, my YouTube channel name uh, is Parag Pal, right? And just visit my website, which is www.civilnotes.com. Okay, so this website is really very helpful for all of you, and you will get lots of civil engineering information and project management information on this website. Okay, so have a nice day, guys. Bye bye.